Let's look at how to name chemical compounds. Now, when naming chemical compounds, we need to remember that we have two main categories that are molecular compounds and ionic compounds. Molecular compounds are made by nonmetals bonded together, while the ionic compounds will contain a metal. So when looking at a compound like NO, before we name it, we first need to decide if it's a molecular or ionic compound. Now, in this case, both nitrogen and oxygen are non-metals, thus this compound is a molecular compound. Now, the naming of molecular compounds is fairly simple. We always name the first element that appears as it is named as an element, so nitrogen. And then we take the second element and we name it, but we're going to change its ending in IDE. So this will be nitrogen oxide. Now, one of the important things to remember is that if we want to distinguish compounds that have the same elements but in different numbers, we need to provide a method. So if we have N2O, we cannot call it nitrogen oxide again because it would have the same name. So we're going to use prefixes in order to indicate how many elements there are in a given compound. And we will use Greek prefixes. So in this case, this element will be named dinitrogen monoxide. Now, instead of writing monoxide, we're going to run it together and call it monoxide, which means that this will be nitrogen monoxide. So that will be its most correct name. Normally, the mono before the first element is omitted. So in this case, we don't need to call it mononitrogen monoxide, but simply nitrogen monoxide. What if we have something like N2O4? In this case, it will be dinitrogen tetraoxide. And again, instead of saying tetraoxide, I'm going to run it together and call it tetroxide. So that is for molecular compounds. When it comes to ionic compounds, we have similar rules. So if we have NaCl, we're going to call this sodium chloride. For the ionic compounds, we are not going to use Greek prefixes. So if our metal is in the main group in the periodic table, then we simply name the first element and then the second element followed by this IDE, so changing the ending. So calcium Cai2 will be calcium iodide. So we're not going to add prefixes. But what if we have elements that can change their charge? So in this case, we know that the main group metals always have a fixed charge. So group 1, sodium, always has a positive 1. Calcium in group 2 will always have a positive 2 charge. But if I have iron, I could find myself facing two different compounds, FeO and Fe2O3. And this is because iron, being a transition metal, can have a variable charge. Now, I cannot call both these compounds iron oxide because I wouldn't be able to distinguish which one I'm talking about. So the rule is to indicate in the name which is the charge of the element. Now, the charge can be derived by the one of the nonmetal. So oxygen, we know, always has a negative 2 charge. It always forms negative 2 ions. So in this case, iron, because the molecule is neutral, must have a plus 2 charge. So I'm going to call this compound iron 2 oxide. So what appears here is the charge of the iron. So I'm trying to tell that this compound is formed by Fe2 plus and O 2 minus. This compound, the charge of the oxygen is always -2, so -2 times 3, total charge brought by the oxygen is -6, divided by 2 of the iron gives me a +3 for the iron. So this will be iron 3 oxide. And this 3 is telling me that this compound is formed by iron 3 plus, has an iron 3 plus in it. So the number in Roman numerals is the charge of the ion that composes the ionic molecule. Now there are few exceptions to these rules. So if you have a compound like ZnCl, this will be called zinc chloride, because zinc always has, and it will be zinc Cl2, zinc always has a +2 charge. Now, the other exceptions that can be found in the periodic table are, so we have zinc always +2, even if it's a transition metal, so it will not have a charge indicated. And silver always has a +1, even if it is a transition metal. So AgCl is silver chloride. I do not put the numeral, the Roman numeral 1 for this name. Exceptions in the other direction if you want. So tin and lead can have charges either +2 or +4. So normally the charge for these are indicated. And so PbO2, for example, is lead 4 oxide, and PbO is lead 2 oxide. And these are the most common exceptions that you will encounter. Ionic compounds can also be formed using polyatomic ions. So, for example, sulfate SO4 2 minus is a polyatomic ion, and it's composed by sulfur and oxygen. So the bonds within the polyatomic ion are covalent, which means that this is a molecular ion if you want. But the sulfate can be associated, can be bonded to, for example, a metal. So you could have Na2SO4, and this compound is catalogued as ionic, even if it contains some covalent compounds within here. This will be named sodium sulfate. So it's very simple. They're named following the same identical rules as we've seen for ionic compounds. So if you have Fe2SO4 taken 3 times, now this will be iron 3 sulfate. If you have CaNO3 taken twice, this is calcium nitrate. So if I have a main group element, I don't need to put a numeral, but in this case, for the transition metals, I do have to have the Roman numeral and say iron 3 sulfate. So I need to specify that charge.